So hi guys, it's me Deepak and let us see insertion sort today. So insertion sort is basically a sorted algorithm that builds the sorted array with one item at a time. So let's see the algorithm first so that you have in mind when we are doing this. So we're gonna insert an element first in J, and before J all the elements will be already sorted. So as you can see, we have an I value which is J minus 1. So up to that I all the values will be sorted, and then we are gonna have a condition in while statement that if I is greater than 0 and the element in AI is greater than the key, which is the element we are inserting, is greater than 0, we're gonna swap those elements until we get to the point where the key element or the element we're inserting is greater. So this is basically sorting the array in ascending orders, and let us see in an animation how it actually works. So let's see a scenario where we are going to do a pairwise swapping here, as 3 is smaller than 4, and we are going to swap those elements, and then j will be incremented by 1 and I will be incremented by 1. Here 2 and 4, 2 is basically smaller than 4, so we will swap those elements here. Then we will check again, do the pairwise swapping, because in the while condition we have then 10 and 12. 12 is basically greater than 10, so it will not go into that while loop and there will be no swapping. Then we will increment 1 and 1 and 12. So basically 1 is going to iterate at to the end of the point. So that's the worst part of this algorithm, because there will be scenarios where the last element will have to go to the first element and we have to do pairwise swapping for the whole list at that point. So let's see about the best case scenario in this algorithm, which is basically when the array is already sorted and then it will not go into that while condition. So here as you can see, the element is sorted, array is sorted, so we are just doing check and increment, check and increment. So the time complexity of this algorithm will be big O of n, because there's only just that for loop j equal to 1 to n. And let's see the worst case scenario. So basically when the loop is in descending order, because the last element will be basically moving to the first element, and basically all the so it will be not big, so time complexity will be a quadratic function. It's not n square, but you can say, so you can say it's basically big O of n square. So let's see the code. I'm going to type that code in C++, and you can do it in any language, Python, Java. So let's import the libraries using namespace std, and so this all is basically a simple code here. So first let's light the driver code here. Driver code means the main function, because in C++ the code is basically run with whatever you write in that main body. So we're gonna start by typing the array function. Array here, array is a basic data structure with the memory in a contiguous order. Basically it's like if you're starting from 0, then 4, then 8, then 16. So let's see the size of the array. So I'm going to use size of function. If you're in I think in Java there's a length function or dot len, I don't remember, but so I'm going to size, then I'm going to create a function insertion sort, where I'm going to pass the array and the size of the array, and then the print function, so to print the array, so that you can see if the output is basically correct or not. So let's see, let's first type the print function. It's basically the easiest part of this whole program. Basically this whole function is easy, it's not that difficult. So I'm passing array and the size of the array. Then I'm gonna, so I have written a for loop from 0 to n, not equal to n, because array start from 0 to n minus 1. Then see out error like usual. Now let's create a void function for insertion sort, and I'm passing array, and so you have to declare array for every function because it's localized to that function only. I'm not declaring those global, so you have to declare it every time. Now let's iterate and use a for loop. As you can see, I'm going from 1, not 0, because j will be always be one step greater and I will be smaller. And so basically when you're using insertion sort, you believe that the elements before j are already sorted. That's why you do pairwise swapping. You're basically inserting you're not actually inserting, but you have to believe that you're inserting the element to the array, and then you will do pairwise swapping here. So I have created a temporary variable key, and I'm putting the value of array there, and I will be equal to j minus 1, and the while condition I greater than 0, because I will not be negative here, and I will be negative, and we don't want that to happen. That's why this while condition arri greater than key here, because if it's greater than, then we have to swap those. That means that an element is greater than what we are inserting, and it have to be in the right side if you're doing it in ascending order, and then will be decreasing I minus 1 every time. So let's see if it runs or not. So I think we have encountered a bug. What is it? Yeah, there's ARR here, not AR. I not A. You can make those mistakes. Anyone make mistakes. So yeah, we have sorted the array, and this is basically one of the easiest algorithms in the whole data structure and algorithm topic.